All right. Hello, everyone, and welcome to my channel. I am Professor L, and I'm doing live stream for math, math engagement, and math help if you need it. So if you want to do math with me, you're welcome to do that. I am going to go ahead and get started. I'm trying to be efficient. And I'm running fashionably late, so I'm going to go ahead and get into it. What I'm doing is I'm going to be working a problem that's very similar to the one I did yesterday. I thought it was so much fun yesterday. I just wanted to do another one. So I've got one more in this textbook. There were only three, and the word problem I've already worked two of the three, so I might as well work this third one. And yeah, see how it goes. I haven't even looked at it yet. And so it's a little bit less involved than the one yesterday, because the one yesterday I actually went and looked at the solution. It was in there because it was the odd one. But the one I'm working tonight was the even one. And so I don't even have the solution. And I haven't looked at it. So it was the even problem, and we'll just see how it goes. And yeah, systems of linear equations in three variable. So they're not exactly the easiest systems to solve, but they are doable. And it just, a lot of times I would say it involves you employ a method of both the substitution and elimination, and then also that scalar multiplication as well. So again, a scalar is just any number that you choose to multiply matrices by, and it changes the scale. Either makes it smaller if it's a fraction less than 1, and it makes the quantity, the number larger, or the quantity is larger if it's greater than 1. All right, so go ahead and get started, keeping that title. And this one was the even one. All right, so see how it goes. 3x plus 4y plus 2z equals 6. And I have x plus 3y minus 5z, and that equals -7. And I also have 5x plus 7y minus 3z equal 3. And I will just take a moment to make sure I have it copied down correctly. 3x plus 4y plus 2z equals 6. X plus 3y minus 5z equals -7. And 5x plus 7y minus 3z equals 3. So let's see if I can stay more organized and less distracted. We're hoping for 0 tangents tonight. All right, we'll save that for the trigonometry. All right, so I just want to take a moment and pause and look at the problem. I'm trying to do it for at least a minute before I get started. So not been successful, we'll try it again, and I'll just look at the clock. All right, Well, that was about a minute, I think. I didn't have a timer set. I think it's about a minute. All right. So, what I've decided to do is I don't want to solve it the same way I did the one yesterday. I can always do that, especially if you have a variable that has a coefficient of 1 in your equation anywhere, then you can just rearrange that, setting it equal very easily without having to deal with fractions or anything like that. And then you can plug in. And that's what I did yesterday. But I think I can solve this purely elimination and multiplying by scalars, which is more representative of what matrices are. And so that's kind of the method I'm going to approach tonight, I've decided. So we have this system. And there's a unique ordered pair, x, y, z, that satisfies this equation, this system, all three equations. There are multiple ways of solving this. Just like if you're going to go to the library, there's multiple ways you can take to get there. There's a most efficient path to the library. But even that one sometimes has like detours and stuff. You don't know. There could be a stalled car in the middle of the lane and it's causing a big, jam or something. So you just never know. But the attempt is to do it in the least amount of steps as possible. They call it working smarter, not harder, doing less and accomplishing more. And that's kind of what I did yesterday. So I'm going to show just for fun. This is me just having fun. And so I think what I'm going to do is I'm going to try to use purely elimination this time. No substitution. We will have to use substitution whenever we go back and check finally, because you're just plugging in those values to authenticate, but actually coming up with the solutions. Let's try to do just elimination here and see what happens. So I'm looking and I have a negative here and a positive here. So I can actually multiply both of these equations just to start out. I think I'm going to be able to eliminate C pretty quickly out of at least two of them. So what I'm going to do is I'm going to add the first two, and I'm going to add the first and the third. So you can add any two equations together in your system, as long as they're not the same ones. You'll end up with the same equation, obviously. But if I start out and let's do the first and the third first, and so I'm just going to copy it here. I'll start by copying it down. 3x plus 4y plus 2z, and that equals 6. And we'll leave some room here. Let's see how I'm going to organize this. 5x plus 7y minus 3z equal 3. And what I'm going to do here is I'm going to multiply it by, 2 times 3 is 6. So if I multiply 2 times 3 and I multiply 3 times 2, then I'll have plus and minus 6. And that's kind of what I want to do. So we're going to multiply it by the scalar 3, that first equation, and then we're going to take the third equation and multiply it by the scalar of 2, and then we're going to add them together. All right, so we have 3 times 3x, which is 9x. We have, and using that distributive property as a property of real numbers, and it's what allows me to do this. 3 times 4 is 12, so that's plus 12y, and then I've got 3 times 2z, and that is plus 6z. And then I have 3 times 6, which is 18. Nice marker. All right. And so I've got this equation, which is equivalent to this one because each term got multiplied. All of the numbers got multiplied by the quantity 3. So it maintains that proportionality of 3. And so it's not actually changed the value. It's just literally changed the form. And that's the idea behind being able to solve these. All right, so 2 times 5 is 10x. 2 times 7 is 14y. And 2 times negative 3 is negative 6z. And 2 times 3 is 6. All right. So I'm just going to rewrite this one underneath this one here so I can add them cleanly. And just making sure that everything is lined up, the x term, the y term, and the z term, so that we can combine nicely the like terms. So that's plus 12y, and that's plus 6z. That equals 18. All right, so what we're doing is now we're just going to add these equations. And so 10x plus 9x is 19x. 14y plus 12y is, what is that? 26y. And then plus 6 minus 6 is 0. And that equals 6 plus 18, which is 24. All right, perfect. So we have this derivative here. We have this equation right here. And that's perfect. That's what we wanted. We're going to repeat this process of elimination, only now we're going to, which one did I say we're going to do? We're going to do the first 2 now. So we did this one, and now we're going to do this one and this one. So as long as you're adding different equations, then you'll be fine because you're going to come up with that unique derivative equation. I'm not sure what it's called. It's a system, a smaller system that is derived from the larger system. So I've got one of my equations for that system, but there's 2 variables so that I know that I need another one to solve it, essentially. Because and I know I've said this before, but it's worth stating again, when you have a system, for each variable that's introduced to your system, you have to have a separate unique equation in order to solve the system. It's just not possible. So if you have a system that has 2 variables, you need a minimum of 2 equations to solve it. If you have a system of 3 variables, you need a minimum of 3 equations to solve it, and so on and so forth. You can have a bazillion, I know that's not a real math term, but you can have a very large system that has potentially thousands of variables, but then you're dealing with 1,000 separate unique equations in that system, and so then you're looking at like quantum computing to solve those. There's probably computers out there that can do it, but for just the layman here, we're just getting the basics down, like the introduction. This is like, it's kind of groundbreaking stuff, but it's just the basics here. And here I went on a tangent, so. All right. Well, anyway, so I've got to repeat that process. And yeah, so let's just get into it again. All right. So we have these 2 now. And so I notice that I have a negative here and a positive. 5 times 2 is 10. So if I multiply the top equation by 5 and the second equation by 2, I'll be able to eliminate z again. And then I'll have 2 equations with the same variable, and that's kind of what I was trying to do. So we'll just do that. We're going to take this top equation first, and we'll say 3x plus 4y plus 2z equals 6. And I'm going to take the second one, so we'll leave some room, and we'll say x plus 3y minus 5z equal -7. And then I'm going to take this top one, and instead of going to multiply it by 5, and we're going to take the second one, and we're going to multiply it by 2. So 5 times 3 is 15, and that's x. 5 times 4 is 20, and that's y. And then 5 times 2 is plus 10z, and then 5 times 6 is 30. All right, and we have this one. So now we're going to do this one, and we're going to do the same thing, that distributive property. So we've got 2 times x is 2x. 2 times 3 is plus 6y. 2 times -5 is -10z. And 2 times -7 is -14. All right. So now I'm just going to repeat that process I did before, and I'm going to rewrite this one underneath this one, making sure the terms are all lined up so I can quickly add them efficiently. So 15x plus 20y plus 10z equal 30. Perfect. All right, so now I'm just adding these equations, and 15 plus 2 is 17, and that's x. 20 plus 6 is 26, and that's y. And then 10 minus 10 is 0, so we'll just put that 0 in for now. And then 30 minus 14 is 16. And let's see. All right, I think I have my equation here. All right, perfect. So what we're going to do is we're going to compare, and we're going to write our smaller system. Let's just write it here. So we have 19x plus 26y, and that equals 18. Just kidding, it equals 24. Let me not mess that up. 24. And we have this one here is 17x plus 26y equals 16. And that's perfect. I like that because then now I can eliminate y. All I have to do is pick one of these and multiply it by the scalar of -1. And when I do that, then I think I'll do the second one, because when I subtract, then I don't have to like think about, it's just easier. 24 minus 16 is more intuitive than 16 minus 24. So I prefer to keep it positive if I can. And, you know, it just is what it is, you know. But let's go ahead and take this one right here. And I can actually do the math right here, so I have room. I'm trying to stay organized. All right. So if I take 17x plus 26y equals 16, and I multiply that by -1, then I'm essentially just making all my terms negative. So that's -17x minus 26y minus 16. Okay, so I'm going to just do that. I'll just change the terms here. Actually, we can go in. You don't have to do that. We can rewrite it. So I will see if I can fit it in here as a step. We'll do it here. All right. So we're going to say 19x plus 26y equal 24. And then -17x minus 26y equal negative 16. Perfect. And so we're going to add those equations, and we have 19 minus 17 is 2x. 26 minus 26 is 0. And 24 minus 16 is 8. I'm doing too much mental math and I'm tired, so I need to just double check. 24. Okay, good. All right. So we have 2x equal 8. So now we're just dividing off the 2 from both sides, and we're getting x equal 4. Perfect. All right. So it is very satisfying for me whenever I do solve these things. So 4, comma, comma. So we have an x, y, and a z. All right. So now I'm just going to pick one of these that I want to plug in for x and solve for y. And they look about the same to me. So I would just pick, we'll do the second one again. Okay, 17x plus 26y equals 16. And so I have 17 times 4, just plugging in for x, and that's plus 26y, and that equals 16. 17 times 4 is 68, plus 26y equals 16. And now we're going to subtract off, the 68 from both sides. And so it's going to give me 26y equal, what is 68 minus 16? That's 52. Looks like it's 2. 52 divided by, so 52 divided by 26. I think that's 2. Y equal 2. Yeah, it's clean. Good. All right, so we've got y is 2. It's coming to unravel pretty quickly now. I'm just going to pick one of those equations to figure out what z is, and it looks like the only equation that is all positive is that first one, so let's just do that one. Gotta keep it positive. So we have one more here. So we have 3x plus 4y plus 2z equals 6, and plugging in 4 for x and 2 for y. Figure out what z is here. 3 times 4 is 12. 4 times 2 is 8. Plus 2z equals 6. And we have 20 plus 2z equals 6. And we're going to subtract 20 from both sides. And we'll get 2z equal 6 minus 20, that's negative 14. And we'll divide off the 2. We got z equals negative 7. All right, so I put it in my curly braces confidently. However, we should go ahead and be thorough and plug this in and check, make sure that it's the actual solution. And again, the way that you do that is you plug in all these values for each one of these equations, and you make sure you get true statements. So the left side must equal the right side, essentially. So we'll just pull a red check in here. So we'll start here, check. We'll do a check real quick. And so that first one, we've got 3 times 4 plus 4 times 2 plus 2 times negative 7, and that equals 6. So hopefully it does. And so that's 12 plus 8 plus a minus. So when you multiply a plus and a minus, the minus will always win. Negative 14 and 6. So that's 20 minus 14 equals 6, and it does. 6 equals 6. Perfect. Let's take the second one. We've got 4 plus 3 times 2 plus or minus 5 times negative 7, and see if that equals negative 7. Okay, so 4 times, so 4, 3 times 2 is 6. A negative 5 times a negative 7. What did I do wrong? That's not going to work. Wait a second, did it fail? Or did I make a mistake? Well, I was so smooth sailing here. What happened? 5. No. 14, yeah, negative 14, negative 7. The first one checked out. I think we have a problem here. Oh, I was so confident. There's got to be a mistake in here. All right, let's check the third one and see what happened. Okay, this one's a to be continued, and we'll start it. Okay, so we've got 5 times 4 plus 7 times 2 and minus 3 times a negative 7 equals 3. All right, so if this was not negative, let's just try and see if this would work, if it actually would work. I don't think it's going to equal negative 7. 5 times. Okay, it wouldn't work either way, because that's 7 times 3 is 21. 20. So yeah, it only satisfies the first equation, so this is not the solution. And that is case in point of what I'm talking about, is that sometimes you don't get to find the solution, and you need to know that. That's why we checked it. Oh, tragic. But what I'm going to do is I'm going to stop, because honestly, it's been a long day, and the reason why I didn't get to spend any time on this problem before my live stream time is just because I was too busy. There's just not enough hours in a day sometimes. And so, unfortunately, as frustrating as it is, I have to compartmentalize because I have a lot of other things I have to get done today. So what I will do is I will think about this problem a little bit. I'm not going to have time to solve it, I can tell you that. I'm just going to leave it alone probably, and my brain kind of just works on things. So it's just the natural. I'll just let what my brain does naturally. I won't spend any time on it, and it'll be a fun thing to do on Friday, try to figure it out again. And I'll just wipe the slate clean. I'll keep in mind the solution, and we'll just rework it. And honestly, it's really good practice for me. And so I don't consider it time wasted. So we'll go ahead and stop there as a plan, and I'll call that good. Yeah, so thank you so much if you watch my video, and yeah, anytime that you want to show up and hang out and do some math with me, yeah, I'm opening up my board space in this time for students of all ages. So whether you're young and starting out, or you're older and you're trying to revisit some topics and you just want to have like a refresher, or if you have any questions on any of your math, um, I will try to help you. And that's what I'm doing here, and it's why I'm here. So, yeah, I will just show up again tomorrow, same time, same place, and I will stop rambling on. And I feel like I'm getting a little bit more chatty as I'm getting more comfortable with the camera, which might not necessarily always be a good thing. Um, so I will go ahead and sign off, and I will say, see you next time, and bye for now.